Yesterday I talked about how you could integrate cover crops into vegetable production systems. We looked at different cover crops. We looked at their properties and where they can be included, what time they can be planted. But today I'm going to talk more specific about reduced tillage options within vegetable production systems. These are more at commercial scale just because I work mostly with commercial growers. But the principle is the same. How can we reduce the amount of tillage, and what does that bring to us in terms of, there are some issues, for example, soil temperature, moisture, what about weed suppression? So we'll go through some of those aspects of conservation tillage through some of the experiments which we have done at Iowa State over the past 4 to 5 years. What are some of the downsides of tillage? And I believe we all will agree that when we have a heavy downpour, which is becoming more and more common nowadays, either in the spring or later in the fall, we see a lot of erosion. So this is something which we see in our farms out there in Iowa. If there was no cover on the ground, especially late in the fall or early in the spring, you can see these gullies forming and taking away that precious topsoil. And yesterday we learned that it takes, 500 years to make 1 inch of soil. We don't want these soils to leave our fields and farms and go in ditches. We want to preserve it where they should be. A lot of runoff, which take nutrients with them. It decreases soil organic matter, which it takes a lot of time to build organic matter. For 1% increase in organic matter, it typically takes anywhere from 5 to 8 years. So a lot of hard work already put in the soil, you lose that. And of course, you also lose soil structure. Since much of the soil is already gone, you might have, the pore space might differ, the bulk density might change. So these are some of the downsides of tillage in vegetable production systems. Now, in reduced tillage systems, especially for vegetable growers, cover crops are the key. We need a cover crop or some kind of residue which stays on the ground and protects the soil. If you are planning to move into the system, and the reduced tillage system could be 2 types. One could be more of a no-till system, and one could be strip till, where you strip a small section. But irrespective of what reduced tillage system you move into, cover crops are the key. You need to make sure that in the fall you have a nice stand of cover crop. And so this is somewhere in middle of October, a couple of years back. This was seeded end of September, middle of September, so about 1 month. But you can see this was drilled using a Thai pasture pleaser drill. But you see how uniform it is. This is what we want, because what we are hoping for is good stand and good residue later in the spring. Establishing cover crop in the fall, and earlier the better. So in Iowa, typically we would put our cover crop, and this is cereal rye, the one you saw here. We seed it somewhere around end of September. If you can go in a little early, better. The chances are that you won't be able to, because you still have your peppers or tomatoes or other cash crops out in the field. So you will be probably drilling or seeding sometime end of September, beginning of October. We are lucky that cereal rye is a benign cover crop, because all it takes is, as long as the soil temperature is 38 degrees Fahrenheit, it will germinate. So you can plant it even now, even in November, sometimes even into December. But if conservation tillage was the objective, plant earlier, because you need that biomass. Any problem in this field? This was a cover crop plot that was seeded early in September, and you can see we are putting moist irrigation there so that the seeds can germinate. So we plant it, and after like 3 or 4 weeks, this is what the field looks like. Any issue in this picture? Look at the germination of the cover crop. It's very uneven. You can see this patch, there was no, and then some of them did really well. So the picture I showed you here was my second seeding. So this was because this one failed. Just because I want biomass for next spring, and if I have plots which don't have cover crops, it's going to where my treatments will be, in jeopardy. And so we went back and said, why did it not work? Because we used a drill. Dana was managing it. He knew how to manage, and we were going and making sure that the seeds were being dropped, right spacing. But what we found out that the problem was seeding depth. And I feel like many of the growers feel like, oh, rye is okay, it'll come, it's very tough seed. But if the seeding depth is not proper, so in this case, I feel we went to anywhere between 1.5 to 2 inches. And that was too much. Rye did not germinate. in that patch. So it's absolutely critical that we get the right seeding depth and also the moisture. So it was a lesson learned that we cannot just think that rye will come up, you just put it, it'll come up. You need to get the right seeding depth. And so once then we went back in September, we seeded, and then this is how it looks like in October. Now it's the same plot, and you can see how even the germination is. And you can see Dana is very happy as well. This was his project for his master's thesis. So since in Iowa, and many of the conservation tillage systems, we use cereal rye as the cover crop. It's the go-to cover crop. And so the seeding rate, what is an optimum seeding rate? We get that question quite a lot. If you're just planting cereal rye as a cover crop, you will hear anywhere from 1 bushel to 1.5 bushel, which is about 60 pounds per acre to anywhere from 90 pounds per acre. But if you are using cereal rye as a conservation tillage tool, where you want a lot of biomass in the spring so that you can roll it down and make your strips and plant your vegetables in it, you need to seed at a higher rate. And so in this experiment specifically, we used 90 pounds of cereal rye, and we used about 25 pounds per acre of vetch. Now we had some concerns of using vetch if they have hard seeds and if you are not able to manage it. So you don't have to add vetch, you can just straight away use cereal rye. But in that case, you have to up the seeding rate, and what we have found is anywhere from 100 to 110 pounds per acre. So 2 bushels, roughly. And that's the seeding rate for cereal rye. Late August, it's unlikely, but mostly late September seems more reasonable. Timing in just before the rain at the research station, we are fortunate that we can set up the irrigation system. But if you are at a practical scale, look for the rains. The rain is coming the day before or 2 days before, seed your cover crop. If drilling, what we have found that seed rows perpendicular to the desired orientation of the cash crop. Because let's say if we drill it this way, and if we roll it the same direction, there will be still gaps because the drill is about 7.5 inches between rows. So if the cover crop did not grow well, there might be some open spaces. And what would open spaces do? A lot of weeds will start coming up. So that's why if we are seeding the cover crop in this direction, we are rolling it in the other direction. And that's the direction in which I will plant my vegetable plot. So that way, it has helped us to make sure that there is no open space. Now, the other way to get around is if you're broadcasting, then you don't have to worry about it because it will be spread very evenly. But if you're drilling, you do it perpendicular. This is an example how not to do it. This is at a research station east-southeast, Muscatine Island Research Farm, and we were playing around with some cover crop and looking at how much biomass we can produce in a very sandy soil. It's only 0.5% organic matter. And so you can see how thin the stand is. This is early in the spring. And if you roll it in the direction you seed it, you can see these open spaces, and that's not good. And if you plant your vegetables in these rows going this way, you would have a lot of issues with weeds. Another thing which we learned is if you are in a sandy soil and you know there is not much organic matter and you won't be able to get a lot of growth of cereal rye in the spring, you might want to consider to add some nitrogen. And so nowadays, when we do research at this research station, especially sandy soils, we apply about 30 pounds per acre of nitrogen for the cover crop, because otherwise the cover crop won't have enough biomass. It's a little counterintuitive. You think of cover crop sequestering the nitrogen, leftover nitrogen in the fall, and conserving that nitrogen, but that's not the case. Sometimes you have to provide nitrogen to the cover crop so that you can get the biomass in the spring. This is the research station at Ames where you saw the drill working. You can see the stand, pretty thick. And this is when you would like to roll the cover crop. And I'll talk about the roller crimper system where we have a crimper that rolls the cover crop. This cereal rye is in anthesis right now. And anthesis means when the pollens are flying. This is the stage we want. And this is in Iowa would be anywhere from 15th of May to 25th of May. That's when we get a good amount of decent biomass and the rye is in anthesis. Be very careful when you're walking these plots because some folks might be allergic to rye pollen. I have a story. I have a student who came with me to do some biomass sampling in these plots, an undergraduate student. We were constantly working, and Ben is talking to me. After some time, Ben is not talking to me. So I turn around, and his face was all swollen just because of the pollens. So I had to immediately take him back to the main office, and we had to make sure that he's okay. Some people are really allergic to these pollens from cereal rye. And there could be a lot of pollen in this plot. This is a lot of biomass out there. So anthesis, when is the right time to terminate? You can see the pollens hanging out here, the anthers hanging out here. If you're looking for hairy vetch, the ideal time to roll them is when it is at the early pod stage. I think it is easier said than done, because this stage comes roughly 2 weeks after this stage. So it's very difficult to match those things together, because you want to roll when the rye is at anthesis, but hairy vetch might not be ready. So it's a little challenging. We just go ahead and do it because we are ready. This is the right stage for cereal rye. There is a cultivar of hairy vetch called Purple Bounty that is supposed to come to this stage, the early pod stage, maybe week to 10 days early. So if you are planning to use hairy vetch, maybe using that cultivar would be better, Purple Bounty. It was developed by USDA, the Maryland Research Station, the ARS there. So this is the spot, this is the time when we want to roll the cover crop. Now, how many of you have seen or used the roller crimper before? Few of you, okay. And so this is a tool which has been in the industry for about 10 years now. This is 10.5 feet long, and it costed us at that time about $2,600. I think the price might have come down. This is a unit which is a drum. There is empty space in here. You fill water in that drum. And when this is full of water, it weighs about 2,250 pounds. So it's pretty heavy. It has these blades called the chevron type blades. And when these blades roll over that cover crop, you are crimping the cover crop. You're killing the cover crop. So you are not flail mowing like I showed you yesterday. You are just rolling this so that the cover crop goes down, and these blades cut the cover crop at 2 or 3 different locations, cuts the vascular system so no water flows, and the cover crop will eventually die. It will become brown in about 3 to 4 weeks. So this has been very helpful, especially if you are in the conservation tillage system. Flail mower will completely chop the cover crop, and that residue won't be there till the end of the season. So with this, it just rolls the cover crop lays down there and slowly dies. But that mat will be there for the entire season. That's what you want. You want weed suppression. But with the flail mower, it'll be okay for a few month and a half, but then that cover crop will go away. So that's why we use the roller crimper. So this is how it works. We mount it in the front of the tractor, and we have done both ways. We have mounted it at the back of the tractor and the front is the better. It's a better option because it crimps the cereal rye better if you have it in the front. So one pass of that roller crimper, this is what it'll look like. You can see that we haven't gone through this stand here, but look at this area. So this is just one pass, driving at about 3 to 4 miles per hour. And that's also a trick. You don't want to drive too fast. You don't want to drive too slow. So anywhere from 3 to 4 miles per hour, you will get this. So you have to go only once. And that's also a question people have. Okay, should I go over it twice? Or is one enough? We found that one pass is enough. So again, rolling in the direction perpendicular to the planting. If you go and crimp before the plant hits the anthesis stage, the plant might not die. That's why it is very critical that we terminate it when the cereal rye is at the anthesis stage. So I mentioned about front and back. This is another, again, this is at Muscatine. We put it at the back of the tractor to crimp. And what we found is that the roller crimper was not doing a great job of crimping that cover crop. And that is because before the crimper goes over the cover crop, the tractor tires have gone over it before. So the tractor tire has just pushed it down, and when the crimper comes, there's nothing to crimp. It's all flat already. So we found that it will kill, but there are more chances of that cover crop, being alive. And if the wind blows in the opposite direction, you'll see the cover crop standing. So that's why we suggest that it's better to put it in the front of the tractor. Again, once the roller crimper has gone through, you can see the thick mat here, which is very pleasing to the eye, and we are very optimistic. But there are some challenges to this also when you have such a heavy residue out there. Then we actually come with a strip tiller. This is a Hiniker 6000 strip tiller. This is a single unit. Most of the corn and soybean growers are more familiar with that if they do strip till. And this unit will go. This has a coulter in the front that cuts the residue. There are discs here that shake up the soil in there. This is a basket, roller basket, which flattens the soil. So it will create a till region of about 8 inches in that residue. Now, the challenge is think of this residue and imagine running that Hiniker 6000 through this. It is a nightmare because it's so much of residue, and the rye will just get entangled here and here, everywhere. And so even though there are coulters here that cut the residue, it's difficult to keep it away. And we found it the hard way. And this actually unit is more designed to be in very low residue systems, not like this heavy residue. So what we found is, now what we do is we make our first pass with the strip tiller in the fall, not in the spring, in the fall. So we seed our cover crop, wait for about 8 weeks, and after that, I'll go with the strip tiller and strip, make my strips already in the fall. So in the spring, when I go and strip, that strip is already open. There is no cover crop in there, so it's easier to strip till. Some other growers which have found another way around it, and what they do is when they drill, they plug some of the holes of the drill so that the cover crops don't fall in those areas. So they already create a strip in the field that way. So this is how it look like, easier next spring. That being said, there is promise of using conservation tillage and strip till, but there are limits and there are issues in this system. And what are the problems we are facing? Many of the researchers have cited reduced soil temperature. Under NT stands for no-till and conventional till system. So if you look at a conventional till versus no-till, it's observed that the soil temperatures are lower just because of the heavy mat of residue which is sitting on the top of the soil. There is a lot of reduction of soil temperature because of the surface mulch. If you have mulch versus no mulch, you have seen temperature differences. Nitrogen availability. Now talk about nitrogen under organic production systems. We are already limited, and we have to add compost and other nitrogen fertilizers. On top of that, if you have limitations just because of the residue, poor no-till yield associated with lower soil nitrates, roller crimped rye causes nitrogen immobilization, because that even though that rye will die in 4 or 5 weeks, but still a lot of nitrogen is tied up in there, and there could be immobilization because of the microbial consumption of that nitrogen. So studies have shown that there are challenges in this system. So what we tried to do is we designed an experiment where we set up 3 different treatments side by side. A no-till system. Even though it's called no-till, there's still a little bit of opening. It's about 2-3 inch opening to put my transplants in there. This is pepper. A strip till system, and then a conventional till system. And we made these plots side by side. These are about 50 feet by 30 feet plots, and they're replicated 4 times, but side by side, so we can compare differences. And on top of that, we also wanted to answer the question of fertilizer application in organic systems, especially growing vegetables. Should we apply fertilizer pre-plant only? That's a question for organic systems. Conventional growers would split their nitrogen into 3 applications, 1/3 in the beginning, and then later through drip irrigation, remaining 2/3. But organic growers, what should they do? Should they just apply all the dehydrated chicken manure or the compost all at once, or should they be splitting using some organic liquid fertilizer? So we had a treatment in which we applied all at once. And the other treatment, what we did, we applied 2/3 of the fertilizer requirement of that crop immediately at the time of making the strips and no-till. And the remaining 1/3, we send it through drip irrigation. And so there's a fish-based product called Phytamin, Phytamin. We use that to supplement and wanted to compare, some clear practical observations of applying all the fertilizer at once in the beginning versus splitting. In conventional system, you need to split, otherwise that nitrogen will leach away. But in organic, we don't know, so that's why we wanted to try that. So we use the fish. And we also had a treatment in which we did not apply any fertilizer because we want to compare the differences. And for publishing this work, we need to show a control treatment. So for a timeline, just wanted to share this with you. We probably seed the cover crop this time, strip till in November, December, just so that make that first pass. Baseline soil analysis. We do cover crop biomass in the spring. Before we roll it down, we want to see how much of biomass we generated. in there. Then sometime in June in Iowa, about, I would say, beginning of June, we would go and transplant. We collected data, temperature, moisture throughout the season. We collected weed biomass. We are looking at some microbial differences in soil, depending on conventional till versus no-till and strip-till. We collected lysimeter. This is the nitrate being leached out of these systems. We did that. So a lot of work went in there. We looked at plant data, harvest of broccoli, probably somewhere in this stage. And then we've moved into pepper, which is somewhere in this stage. And that's how we finished that 1 year. So we did this for 2 years in a row. And then finally, once you're done, we seed a cover crop back again for the next season. Although we did not grow it here, we moved to a different location because for organic systems, you cannot have the same crop again the next year. You need to have your crop rotation. Coming back to spring, once we have rolled, you can see rye. It's almost brown. We were using the Holland transplanter. You can see the students back there. They're putting the transplants in. And there were some challenges. Even though you went with that strip tiller there, being more realistic here, the seed bed is still rough. There are still chunks in there. It's not like how when you run a rototiller. We had some issues. You can see that here, some more chunkier soil lying there. But we made sure that once the transplanter put the transplant in there, this is broccoli here, we walked around, we walked back it and make sure that there's good transplant to soil contact, because otherwise you don't want the transplant to sit in this hollow air space. Just because the tillage was not very fine. Later during the season, we collected weed biomass, and we collected the weed biomass both within the row where the transplants are, and also between the rows where the cover crop mulches. And we did find, so this is CT stands for conventional till, NT stands for no-till, and ST stands for strip-till. So all these three treatments. Blue is the between row biomass of weeds, and white is the in row. So you can see between row, the amount of weeds that were collected in conventional till was way higher. There's no blue bar for the no-till and the strip-till. There were no weeds there, just because the cover crop with that high biomass suppressed the weeds. If you look at the in-row weeds, definitely there are a lot of in-row weeds in conventional till. There are in-row weeds in strip-till and no-till too, because that soil is exposed. So you have to go at some point and hoe or remove it. But statistically, A here is higher than CD and BC. So no difference here, but there's way more weeds in row in the conventional till system. We kind of found the same thing in the second year. You can see conventional till system, we have more between row versus these two here. And then with the in row, kind of the same. So statistically, I should say these are the same. And that is because, so you might find, why did it do so well here and it did not do so well at this year? And that's because when we move to a different site, it also depends on the previous history of that plot. So if the plot was very weedy, it was not managed well before, there could be many perennial weeds. So we had Canadian thistle there and many weeds already there. So that's why this plot had higher weed pressure when we went in versus this plot which did not have much weed pressure. So it depends on the history of the plot as well. What about soil temperature? This was a good indicator to answer that question. Does the soil temperature differ between conventional till, no-till, and strip-till? So, and the soil temperature is 6 inches below the soil. We divided the season into 3, just 1.5 months, 1.5. So we have good idea of what the temperature changes are throughout the growing season. So we divided into early, mid, and late. And we collected minimum temperatures. We collected the mean temperature, soil temperature, and the maximum soil temperature in all those 3 treatments which are here. Right off the bat, what we see is that late in the season, we found no significant difference in soil temperature. This is late in the season, once the crop is kind of getting done. Again, here in the mid-season, for the minimum temperatures, no significant difference. And if you look at the minimum temperature, mean and maximum in the conventional till, you can see about 68 degree Fahrenheit, 72, the mean is 72, and the maximum is about 76, 77. This year, 2015, kind of the same. So between these 2 years, we are very much similar. So we are getting consistent data that the conventional tillage system, the mean temperature of the soil is somewhere in that 72 to 75 range. Now the interesting thing is, if you look at the strip till and no-till system, for the minimum temperature, or let's focus on the mean temperature, you can see they are statistically lower than the conventional system. How much lower? Let's say about 2 to 3 degree difference. So that's the difference in soil temperature between a conventional till system and a strip till and no-till system. So that's an easy number to remember. It's a small number, 2 to 3, but for the growth of the plant, that could make a huge difference of how quickly it will grow, how quickly it will yield, and how much it will produce. So we do see temperatures are low in the conventional, in the strip till and the no-till system. Both years, you saw that here in 2014, this is 2015, and you can see these two numbers are lower than these two numbers are lower than these, so we do see that consistent difference. In 2015, we saw that the no-till had even lower soil temperature as compared to strip till. So strip till is helping to increase the temperature by a degree versus a no-till system. And again, the no-till system is not completely, it's not free of, there's some movement of the soil because you want to put your transplant in there. What about the soil moisture? And what we found is that there is no statistically significant difference in soil moisture for conventional till, strip till, and no-till for one of the years. But if you look at 2015, we do find differences in the early and the mid-season, is that the soil is holding more moisture in the strip till and the no-till system than a conventional till system. So now we are seeing some benefits. It can very much depend on the rainfall you got that year. This was a wet year for us, so not much differences. The sensor was capturing almost the same amount of moisture, but for 2015, little drier, and when it was drier, we saw that the strip till and the no-till system is holding on to that moisture as the plant grows. This is a very complicated slide. We are looking at microbial biomass. So we are answering the question, is there a difference in the amount of microbes that are in the soil in a no-till versus conventional till versus strip till? And what we found is more or less no difference. This is the first year and the second year. So in 2 years, it's very difficult to find significant differences in microbial biomass. So if you look at the contrast here, only depth was significant. We took soil samples at 2 depths, at 7.5 and about 15 inches, so 2 depths. The more deeper you go, the less microbial biomass, and which is true because the organic matter is mostly in the top. But based on the conventional till, no-till, conventional till, strip till, no-till, strip till, no difference in microbial biomass. They're very much in the same. The only difference we found is for microbial biomass nitrogen, not carbon. So this is carbon, this is nitrogen. And we do find early in the season between conventional till and no-till, it's on the borderline. There's some difference in microbial biomass, but not very significant. What the take home would be, there are differences, but not very significant for microbial biomass, just based on 1 or 2 years of, actually in this case, only 1 year, because we moved to a different site the next year. If you keep doing that over years at the same site, you might find differences. We also do this measurement called the CLPP, community level physiological profiling. We did not find any difference in diversity as well. This is just to show you that system. This is not from that study, and I showed you yesterday too, that these plates tell us what the diversity of the microbes is in the soil. The more color they have, the more diverse microorganisms there are. So in a strip till, no-till, conventional till, no difference. I feel like much of it is masked because the organic matter to begin with is about 3%. So there's a lot of organic matter, there's a heavy load of microbes already there. So 1 year of conventional strip, no-till didn't make any difference in the microbial biomass, in the diversity. What about the yield for broccoli? So focusing on the broccoli crop, 2014, conventional till produced more just because, the temperature is higher, plants grew faster, the nitrogen is applied in a very nice split manner, so we had higher yields. We had lower yields for the no-till and the strip till. But in 2015, we did not find any difference. The yield was the same across the board. Conventional till, no-till, strip till. So now this is good news, that even in such systems where you are not tilling completely, you are getting equivalent yields. What about the differences in fertility? Did the fertility make any difference in yield? So if you look at pre-plant fertilizer, split application of fertilizer versus no fertilizer, obviously no fertilizer is always going to be at the bottom because there's no fertilizer. And I'll show you a picture of how the plants look like. But between pre-plant and split, no difference. So what it tells us is that apply all the fertilizer at the same time in the beginning. You don't need to split. In such a system where you're using, let's say, dehydrated chicken manure and you're trying to supplement fish emulsion after that. You don't have to. You can apply all the fertilizer at the same time in that strip. So that saves, labor, that saves time later on in the season. In 2015, same thing. We found that there was no difference between pre-plant and split application of fertilizer. Applying all at once is the easiest way and getting the same amount of yield. This was the plot, broccoli plot, how it looked like. You can see this is the conventional till plot. We have a no-till plot here, and we have a strip-till plot on this side. You might wonder, what are these rows? Why are these so small? Because these are the no fertilizer treatments. So if you don't apply any fertilizer, this is what your broccoli would look like. If you apply fertilizer, they'll be better. So absolutely, fertility is critical when we are talking about vegetables, and we should always make sure that there's enough fertility in the soil. Oftentimes we disregard it or don't pay much attention to fertility, but you need to keep it up there. Otherwise, you won't get that productivity out of that plant. Now, I want to be very realistic here. We have to face the reality. The mulch does a good job of suppressing weeds, but doesn't suppress all the weeds. So you can see in this picture, you can see some purslane slowly moving in, especially from the rows here. There's some grasses coming up. So there will be weeds. And what we do is we just go and we hoe in that strip area, so that way we keep it clean. If there are too many big weeds here, we go and pull it out. And that's still a challenge, if you have bigger area where you have a strip till system like this, and if you have weeds coming all through that mat, it's difficult to go and manage. And that's why we pay a lot of attention in making sure that the cover crop is seeded well, strip tilled well, and you have a lot of biomass, so that you don't have issues of weeds coming between the rows. So summarizing that study, you have to make sure you establish a good stand of cover crop. Strip tilling, make sure you terminate it at the right time. You can make the second pass if needed. Usually with one pass of roller crimper, we were able to manage the cover crop. Pre-plant in-row fertilizer application all applied at once is okay. Use of quality transplants. In organic systems, we need to make sure that we are already fighting an uphill battle. Microbes have to be active for the nitrogen to be available, pest and disease problems later on. So we need to make sure we put a healthy transplant to begin with, so that you have better chance of success. And yes, weeds need to be pulled out if there are too big weeds out there. This is another study I want to quickly go through. This is a pumpkin study which we did. This is at the Muscatine Island Research Farm, that sandy soil I was talking about. Look at the stand here, not very dense as what you saw in Ames, which is central part of Iowa. Here we tried different rates of cereal rye. 60 pounds per acre, 120 pounds per acre, 180 pounds per acre of cereal rye, and see what is the sweet spot for the cereal rye seeding rate for conservation tillage systems. So we did find that when we increased, this R stands for cereal rye, when we increase the seeding rate of cereal rye, the cover crop biomass does increase. But when you go up to 180 pounds per acre, there is no statistically significant difference. So why waste money on that extra 60 pounds of rye? And so the max we found was 120. So there is difference between 60 and 120. Because the rate is double, you have more biomass, and that's it. That's the sweet spot. So 110 is at the more loamy soil. This is a more sandy soil. 120 is what we found. That should be the seeding rate for cereal rye. What did it look like for the pumpkin study? You can see the weeds in the no cover crop treatment. There was no cover crop, and then we just let the weeds grow, and we went back and hoed after this data. After the weed biomass data was taken, you can see we collected some biomass samples from here, but see how it looks like versus something like this. Now, did it do well as compared to the central Ames site? I don't think so, just because of the stand of the cereal rye. It was not very thick, and when it's not thick, you see weeds slowly trying to emerge from there. So that's why making sure you have a good stand of cereal rye is absolutely critical. So that was the 60 pound per acre. This is the 120 pound per acre. I did a little better than 60. And this is the 180 pounds per acre. So we didn't find much difference between 120 and 160. Still, there are some weeds that are coming up, and pumpkins were doing okay. This is not an organic, this was a conventional study, so we are using conventional fertilizers. What about the weed biomass? Broadleaf and grasses, definitely way higher up here for the no cover crop treatment versus 60 pound, 120 pound, and 180 pounds, all lower than the no cover crop, so that's good. So this is the harvest late in the fall. What was the pumpkin yield? This is marketable weight, the blue lines here. And we did not find a significant difference between no cover crop and the cover crop treatment. Just because it's a conventional system, we are providing the fertilizer. Once we collected the weed biomass, we went and hoed, we cleaned up the plot, so things were all okay after that. And not much difference in the non-marketable fruit either. But one thing which we noticed is that in the cover crop treatment in which we strip tilled versus the no cover crop treatment, the pumpkins came out a bit more cleaner, and you might have observed that too. There's less soil sticking to the pumpkins, and so this is from that treatment versus something like this. This was in the no cover crop. They were sitting in the soil. Sometimes they become this warty. Maybe we were late in harvesting, but you can see that salt here because of the fertilizer sitting up there, and you don't want a pumpkin like that. The other thing we found is this Plectosporium spot, which is a disease. And we saw it in both strip till and the no cover crop treatment, but it was more in the no cover crop treatment. So this spot was showing up more on those pumpkins. So while we were doing this study, we were doing some on-farm studies with some growers. So this is with Geisler farms, and we were trying to find which cover crop to use for conservation tillage to grow pumpkins. Again, we looked at the number of pumpkins with rot. And if there was no cover crop, they were about, this is about a 20 feet wide plot, and you're looking at 5 rotten ones from the no cover crop versus vetch, which rye and hairy vetch. So we do find that there are less number of pumpkins that are rotten in treatments where you have a cover crop mulch sitting and the pumpkin sitting on top of that mulch. I'll quickly go through another study, which is very similar to the broccoli study I showed you and the pepper study. In this case, what we are trying to focus is on summer squash for these systems, for conservation tillage. So we were using a conventional system of growing summer squash here, black plastic mulch, versus a system where there's cereal rye. Again, not a very heavy stand. We did not do a good job. This was a sandy site at Muscatine, but it's strip tilled and you put your summer squash in there. With soil temperature, this is a very complicated study because we are looking also at row covers. In addition, an RC stands for row cover. What we find is that the blue line, which is the plastic culture, and the no row cover, and this RC, which is red, these are higher. So, plastic culture systems definitely will increase the soil temperature versus the strip till, which is green, and the red. With and without row cover, they are lower. So we do see that the strip till no till system are having low soil temperature. So this study also confirmed that. You might wonder, why are we using row covers? So the hypothesis was, okay, we know that the strip till no till systems are reducing soil temperature. Can we increase plant growth by putting row covers on top of them? And that's why we went that route. And also to protect them from insects, especially for cucurbit crops. The findings from that study, average soil temperature in the plastic culture system was about 1 to 2 degrees Celsius high, so about 4 degrees Fahrenheit. Row covers increased daily minimum soil temperature by about 1 degree. So if you are in a system where your soil temperature will be low, maybe putting a row cover can help increase the temperature a little bit. For air temperature and light quality, you can see there were statistically significant differences between row cover and no row cover. So adding a row cover does increase the temperature by about 3 to 4 degrees, which is nice. We found that both years. And for light intensity, we do see that row cover will decrease the light just because there's a cover on top. And so you won't get enough light intensity. So it can slower the plants down. What my personal observation is, and based on the results from the study, maybe summer squash is not a crop suitable for conservation tillage. And the reason being, when you put summer squash in such a system, you're slowing down the growth of the plant. You don't get to plant early because you want to make sure that your cover crop biomass is very high, and by that time you miss the window of planting, and your summer squash you're harvesting very late. The summer squash is something which comes into the markets very early in the season, so you are not able to capture the earliness market. So that crop is not suitable, but maybe tomatoes, peppers, those might be a bit more suitable. Or pumpkins, which are anyway harvested late in the fall, or for that reason, winter squash. Soil moisture, in this study, early in the season and late in the season, we did find that the strip till systems had higher moisture. They do help to conserve a little bit more moisture as compared to the plastic culture system. Yield, it's all across the board, but what I want to show you here is we did find that the green lines are the strip till system. They are lower. You can see they are lower than the orange. So in summer squash, the strip till actually lowered the yield, and the plastic culture system boosted it. In the pepper and the broccoli study, we did not use plastic. It was bare ground. So some of the take home from there, strip till into roll dry makes early planting a challenge, especially for summer squash. You have to again use high quality transplants, and then we also, since we put the row covers, we need to make sure that we remove the row covers on time so that pollination can happen, because these are cucurbit crops. You want the bees to move around and pollinate the crop. And use of row cover is necessary to catch up on the early growth because of the reduced temperature in the conservation tillage systems.